What's up? What's up? All right. It's time for a 6.1 to 6.3 quest review video as requested by the people, for the people, and also the YouTube subscriptions. Got to monetize this bad boy. All right, let's get going. We're gonna rip the Band-Aid off. We're gonna go graphing right away. Okay. So let's start with graphing this one here. I'm gonna go with light blue for the work here. I'm gonna start with a T-chart. Okay, because I like T-charts. You could do this with transformations. Some of us are okay with that. A lot of us have been doing this kind of a thing. I know I want square root of 0, square root of 1, square root of 4, and you know what? I'm even going to go, oops, don't want to drag me. I'm going to go square root all the way to square root of 9, okay? As long as you have at least 3 points, that's cool, all right? I think Alex requires 4 points, but 3 points is enough for something that's curved. All right, so what x value would give me 0 inside of the radical? So I want to make this piece right here 0. Well, that's going to be -6. And if I plug -6 in, I get the square root of 0 plus 3. That's 3. I'm going to make sure that looks like a 6. There we go. All right. Now, how do I get 1 inside my square root, inside my radical? If I plugged in -5 for x, -5 plus 6 is 1. The square root of 1 is 1 plus 3 is 4. How do I get 4 inside my radical? Well, I'd plug in -2. If I plug in -2 for x, -2 plus 6 is 4. Square root of 4 is 2. Plus 3 is 5. And then lastly, how do I get 9? Well, I'd plug in 3 for x. 3 plus 6 is 9. Square root of 9 is 3. Plus 3 is 6. Woo! Awesome. We're ready to plot this thing. All right. I'm going to get a darker marker up here. Let's go blue. All right. So I've got, what's up, Billy? How we doing? That's awesome. Billy's good. All right. So I'm going to go, let's see here, -6, +3. Then I got -5, +4. -2, +5. And then 3, 6. Awesome sauce. This is just an equation, not an inequality. All right. So, boom. There we go. We got our graph. We're likely going to also ask for domain and range, right? So domain, range. Let's do it. There are 2 ways of writing this. So for my domain, I'm starting at -6 and I'm going to infinity. I don't know if my hands actually go the right way or if it's inverted. But anyways, so we're going to say that x is greater than or equal to -6. Another acceptable form would be -6 to positive infinity. Range, let's talk about my y's. I start as low as 3 and I go on up to infinity. So either y is greater than or equal to 3, or you can have 3 bracketed, parenthesis, or then infinity with a parenthesis. All right, there's my domain and range. I got my graph. I got my T-chart. All wonderful things. You don't have to necessarily do a T-chart, but it definitely helps to stay organized. And if you mess something up or whatever, we can give you some partial credit. Cool? Awesome sauce. Time for some inverse action. So now we're going to find the inverse of f of x, and then we're also going to graph both of these, okay? So I'm going to do my inverse in a light blue. So I'm going to switch my x and y. So it's going to be x equals -2/3 y plus 6. And now I need to subtract 6. So I get x minus 6 equals -2/3 y. And then I'll divide by -2/3 or multiply by -3 over, oops, not 3 over 3, -3 over 2. Okay, so I can multiply by its reciprocal. Not opposite reciprocal, but reciprocal. A lot of times when we start flipping things, people think like, oh, do I change the sign too? You're thinking of perpendicular slopes. All right, so if I distribute that in, I get -3 over 2x, and then I have -3 times -6 is 18, divided by 2 is 9, equals y. Cool. Awesome sauce. So this is f inverse of x equals -3 over 2x plus 9. That is my inverse. Awesome. All right. Now I need to graph both of these. I'm going to start with the green one. I'll go darker green for this so we can see it a little better, and then we'll do darker blue for the other one. So here I would start at +6, and then I'm going to go down 2 over 3. So down 2 over 3. We only need 2 points, but, sometimes it's just fun to go and connect the dots. You know what I'm saying? All right. Ooh, look at that. I'll use my ruler here because I got one handy if I can learn. There we go. Right? Boom. There it is. That's my graph of f of x, right? Now, the inverse, I'll do in dark blue, starts at -9. Your other option here, and I'll show it actually, sorry, it starts at +9. All right, so I got my y-intercept of 9, and I'm going to go down 3 over 2, down 3 over 2, down 3 over 2. Cool. I'm going to connect all these dots. All right, that's pretty close. Awesome. All right, now what we can see is, if I pop that ruler back up and I throw it down at a 45 here, and I were to say, put this yellow line, this y equals x line, you can see those two, it's sometimes harder to see like on the lines themselves, but they reflect over that yellow line. All right, another thing we want to talk about here is sometimes the two functions that we get, one of them is kind of difficult to do. If you remember on your review, I believe, one of them ends up having like a fraction for a y-intercept, and oh, that's terrible. All right, so graphing that's not that great. You can pick some points and get creative, that's cool, but one thing we can look at here is that if I take a look at, say, this point right here, 0, 6 on the green one, we're going to see 6, 0 on the blue one. If I have 3, 4, which is right here, I have 4, 3, which is right there. So if I have one of the graphs, I can just switch my x and y coordinates to graph the other one, if it's not that easy to graph. Here we were lucky. They both had nice y-intercepts, so it's an easy start point, work with the slopes. But if that's not the case, you can always switch your x and y coordinates. All right? That's awesome. That's it for graphing, okay? That's all you got for graphing. All right, we're going to do some function operations here. So if I have f of x and g of x, let's do f of g. It can be written like this. It can be written just like this. It can be written like that. It's awesome. All right, so lots of different ways we can notate this. This is one of the ways. You can also have just f of x plus g of x. So you should be fluent, as we say, in many different notations. Let's go with that one that we have now. All right, so all it is 2x squared plus 3, which is our f, plus x minus 1, which is our g. And now I can combine like terms if possible. I have 2x squared, and then I have plus x, and then 3 and -1 gives me 2. That's it. Donezo with that one. All right? Love it. Wonderful. I'm going to select that, use my fancy technology here. We're going to make it small. Oh, no, that wasn't it. That was a bad tech flex. There we go. Now I can drag it off to the side. Right, we did that one. Next one, I'll do it in light blue. Oh, change that one too. So let's do f minus g, okay? Got to be careful with this one because there's the subtraction, so we got to distribute that negative. So I'm going to have 2x squared plus 3 minus, and then I'm going to throw some parentheses around that so that I remember to distribute my negative, and I get 2x squared plus 3 minus x plus 1 in this case, and I get 2x squared minus x plus 4 as my final answer. Woo! Awesome sauce. Excellent. Any questions? You can't ask those questions. Billy, how about you, man? Cool. Billy's rocking it. He's just cruising. He's just cruising. How about you, Ava? No. Cool. Ava's cruising too. All righty. Next one. Let's do some multiplication, shall we? You know what? I'll stay blue. Okay. Multiplication. F times G. I'll do this notation now. Woo! It's crazy. All right. So I've got 2 x squared plus 3. And then I have x minus 1. Multiplication, so I got to FOIL these together. All right, so 2x squared times x is going to be 2x cubed. 2x squared times -1 is negative 2x squared. And then I've got 3 times x is 3x, and then 3 times -1 is -3. There's nothing to combine here. I'm diggity done. Oh, wonderful. That was cool. I'm going to select it again. I'm liking this little, minimize the work kind of a thing. It's kind of cool. There we go. Whee! I love it. Awesome. It's cool. All righty. How about f divided by? There we go. Oops. Should probably get a marker back. F divided by g. How about I'll do this notation now. Cool. So if I have that one, there's really two parts, right? First off, it's just 2x squared plus 3 divided by x minus 1. The next part, we have to figure out our domain restrictions, okay? So this is where x cannot equal. I want to see what will make this denominator here equal to 0. Now, it's pretty easy to see with this one, but if we had something a little more complicated in the denominator, we would want to set this equal to 0, solve for x, and now I know that x cannot equal 1. Okay? So we set it equal to 0, solve for x, find out what x equals so we can tell us what x does not equal, right? A little weird, but it gets the point across. All right, gets it done, gets the job done. Wonderful, there we go. So both parts are needed. We can even ask just like for certain questions, we can say, what are the restrictions on the domain? Whether it be something for this or for a radical function that we've dealt with in this chapter, or really on the final exam too, we can just say, what are the domain restrictions and not even actually ask you to do all the math. All right? What's up? All righty, next one. Let's do this. We've got all of our different operations. How about some compositions? I love compositions. They're the best. All right, so let's say we've got f of g. We're just doing f and then g for all these. That's okay with me, though. So for this one, g gets plugged into f. So I'm going to have 2 and then parentheses x minus 1 squared plus 3. And the question comes up is like, hey, do I have to FOIL here? Do I have to write it out like that? Yes, mathematically accurate would be 2, and then you can write them out twice if that helps, because that's the same as saying that binomial squared. And now I have to FOIL those two together. I do have to account for that 2 out front, but we'll do that in a sec. So x times x is x squared. Then I'm going to have negative x, and negative x gives me negative 2x. I'm combining like terms on the fly because I am dope. And then we've got plus 1 there. And then don't forget about that plus 3 at the end. So now I've got 2x squared, if I'm distributing that 2 out front, right? I'm distributing that guy. Minus 4x plus 2 plus 3. And then my final answer here, I'm going to combine those two. And I want to move this guy out of the way a little bit more. Whoop. Cool. And now we've got 2x squared minus 4x plus 5. Awesome. There is my final answer for f of g. Do not make the mistake of distributing into the binomial. That is not allowed. Got to FOIL it out. Okay. Can make that one smaller now. Oh man, this is some crazy stuff. All right. And then last one for compositions here, or for operations of functions. So let's say we have, I'm going to switch it up, g of f of 2. All right. So what do we do here? There's a couple options. You could get the composition and then substitute 2 in, but my personal preference is I'm going to plug 2 into my f function first, okay? So I'm going to do f of 2. That's going to give me 2 parentheses 2 squared plus 3. So I'm going to have 2 squared is 4 times 2 is 8 plus 3 gives me 11. Now I'm going to take that 11 and I'm going to plug it in to the g function. So now I'll have g of 11. And I'm just going to have 11 minus 1 gives me 10. So my final answer here is 10. All right? Boom. Awesome sauce. Fantastic. I think that's good for function operations. We'll do a little more after this. All righty, here. One more. I almost forgot we want to do a little more compositions. So it says, are these two functions inverses of each other, right? Show using compositions, let's say. Okay? I can spell compositions. Compositions. Cool. All righty. So if I just asked you wouldn't need to use compositions, but the directions will generally specifically state show using compositions. So here's what we do with compositions. I'm going to do f of g. And if that equals x, then I will do g of f. And if they both end up equaling x, then they are inverses. Okay? So let's do that. So I'm going to plug g into f. Okay? So I have 2 parentheses 1/2 x plus 6 plus 3. And now I have x plus 12 plus 3. I have x plus 15. Is that x? No. So these are not inverses of each other. Okay? I can stop here. Not inverses. Inverses is. All right, not inverses, because their compositions did not equal x. If this were just x right at the end here, if I just said equals x and the 15 was not there, then I would need to do g of f and see if that equals x, right? Question mark, does it equal x? If they both did, then they are inverses of each other. But that was not the case here, so I am done. Cool. Awesome. Wonderful. Next problem. All right, next problem. Is this graph below here a function, and also is its inverse a function? Well, to figure out if my graph is a function, I need to do the vertical line test. Why don't I take my fancy ruler here, put it at a 90-degree angle, and does this ruler ever intersect it more than once? No, it does not. So this passes the vertical line test. This graph is a function. Yes. All right. Now, for its inverse, I'm going to have to do the horizontal line test. Let me throw that at 0 degrees. Come on now. There we go. All right. Does it ever cross through more than once? Oh, yeah, all the time, right? This is a quartic function, degree of 4. So, nope. There we go. All right. Vertical line test, horizontal line test, and that would be what you could write. So if it ever asks you, like, why is that the case, or justify, or please explain, you can say passes the vertical line test, does not pass the horizontal line test. Coolio. Hey, what's going on right here? That's a multiplicity of 2. Ooh, finals review. That's fun. All right, next one is, what's the domain of the function here? Well, normally we'd be graphing these, and to get a visual as to what that domain is. We can do it without that, but for now, let's go ahead and graph this, just a quick rough sketch. This would move to the right 3 and then up 7, so you'd be somewhere like up in here, and we'd have our graph, right? So this is I moved to the left, as I said right. My apologies. To the right 3 and up 7. Okay, there we go. So that's 7, that's 3. So my domain here would be x is greater than or equal to 3, or 3 to infinity, right? Okay, well, sometimes it's not necessarily as easy to graph, but we really don't even need to graph it. What numbers are not allowed in a square root? Negative numbers, right? So if I were to take x minus 3 and set it greater than or equal to 0, add 3, and I've got the same result as right there, which I could also write as 3 to infinity. So there we go. There's my domain, right? Now let's apply that in a more complicated situation. Same question, but let's say f of x equals, let's go with the square root of, how about 7x? I think I did 7 in class yesterday. How about 5x plus 6, okay? So what are my domain restrictions? Well, I can just take 5x plus 6 is greater than or equal to 0. And now I'm going to solve. So I got 5x is greater than or equal to negative 6. Divide by 5. And we get x is greater than or equal to negative 6 over 5. And you might be like, whoa, bro, wasn't there some kind of a rule with a negative? You're dividing and multiplying and stuff like that with an inequality. Do we need to address that? I thought you'd never ask, but I'm gonna do that. Thank you so much for asking. All right. So either one of these notations are fine for this domain, but the situation you guys were just asking about fictitiously right there, because no one's actually talking to me. I'm just talking to myself. You know what I'm saying? You know what I'm saying, Nick?
Yeah.
He knows what I'm saying. All right. What if I had this? Are you ready? Are you ready? How about 2 minus 10x? All right, so we're going to put that greater than or equal to 0, the part that's inside of my radical. So 2 minus 10x is greater than or equal to 0. So I'm going to have negative 10x is greater than or equal to negative 2. And now since I'm dividing by a negative 10, I have to do this. And now I have 1/5. So that's my new domain restriction here. Or, whoa, it'd be negative infinity to 1/5 would be that equivalent. Probably a little easier to write the inequality so that you don't nearly make the same mistake that I almost just did. All right, I got one more problem for us, and then I think we're gonna call it a day. All righty, is the relation a function, and is its inverse a function? Oh, I love these. These are great, because with like day one, then you completely forgot about it. All right, the inverse, is it a function? Let's see here. The function. Is the relation a function? I know words. I can do words. Caleb. All right. I'm going to look at all my x's. Okay. If my x's were to repeat, then it is not a function. Because what would happen is on a graph, if my x is repeated, I'd have like a point here and I'd have another point up here. It would not pass my vertical line test because it would go through twice, okay? So in this case, none of my x's repeat. We're all good. Okay, so is the relation a function? Yes. All right, is its inverse a function? Which is our horizontal line test, but when we're looking at the ordered pairs here, now I'm trying to see, do my y's repeat? So I'm looking here, here, all good, and uh-oh, I got a couple 7s. So the inverse, nope, not a function. All right, that's it. That was awesome. That was dope. Super cool. I hope you enjoyed. You know, America, freedom, rock and roll Costco, Riverdog Jenny on the gram, Yo Ro, and of course, Mr. Allen Math, no, Mr. Allen Rocks 101 _. I almost messed that up. My goodness. All right. You guys have a wonderful day. See you later.